Hello and welcome back to our FSMQ series. Lesson 6 now. We're on to tangents to circles. I know this is also another GCSE overlap topic. However, there is a bit about the equation of a circle that is new, so we need to go over that first. So at GCSE, you learned the formula x squared plus y squared equals r squared because that was centered at the origin. So 0, 0, if you don't know what the origin is. You should learn that. But at FSMQ, you need to learn the more complex version of that, where you subtract A and you subtract B from the X and Y. And this gives you a given center of AB. The reason we taught the simpler version at GCSE was because A and B are 0 in that instance, and therefore it's so much easier to write, so much easier to understand. But in this case, you just need to know that whatever is in that bracket, you're doing the opposite of that number. So if it's positive, it's going to be a negative in the coordinate. If it's negative, it's going to be a positive coordinate. So how do we actually solve tangent questions? So in this instance, we're told to find the equation of the tangent at 4, 3. And this is a pretty simple question. You'll probably get something harder, but this is just to understand the basic concept. So I'm going to pop 4, 3 onto the graph here and draw the radius between them. Now we want to find out what the gradient of this radius is. So you're going to use whatever formula you learn at GCSE, rise over run, change in y over change in x, y2 minus y1 over x2 minus x1. Whatever you use it to work out the gradient. So in this case, it's a third. And then what you need to know is a tangent is always perpendicular to the radius. So from this, we can use the gradient perpendicular rule to do the opposite of the fraction, flip it, and then make it negative. So we get minus 3 as the gradient of this tangent. From here, you can write out, substitute it into y equals mx plus c, and then substitute in the point at which it is tangent. So we substituted in 4 and 3, and then rearrange, c is equal to 15. So therefore, the full equation is y equals minus 3x plus 15. Right, so in our practice question next, we're going to have a look at something a little bit more complex. It requires finding two tangents. So let's get into that.
So here's our first practice question for today. The 2 points minus 3, 0 and 2, 3 sit on the circle x minus 1 squared plus y plus 1 squared equals 17. Find where the tangents from these points intersect. So first what we're going to need to do is use this equation up here to find out what the centre is. And in this case, it's going to be the opposite of whatever it was, so 1 minus 1. Here we can work out the gradient of the first set of points. So this is change in y over change in x. This delta sign just means change in. So we're going to do the center point y, take away the y of the second point, and then x. And that comes out to minus 1 over 4. So minus a quarter. But obviously then we're going to flip it so that m of the tangent, I'm going to put t actually, is just 4. Because you take away the negative and then you flip the fraction. We can then work that out. So y equals 4x plus c. Substitute in this. We got 0 equals minus 12 plus c. c equals 12. Draw an arrow. and then we have y equals 4x plus 12 is our final equation for that. Next point, we have changing y over changing x again, which is minus 1 minus 3 over 1 minus 2. This comes out to minus 4 over minus 1, which equals normal 4. Therefore, the tangent's gradient is going to be negative 1 over 4. And you can tell these are actually parallel because, you know, they're both just swapped. From this, y equals minus 1 over 4x plus c. Substitute in these values this time. We have 3 equals minus a half plus c. So therefore, c is equal to 7 over 2. Substitute that back in. We have y equals minus 1 over 4x plus 7 over 2. Now, from here, we can set these equal to each other because they're both equal to y. If we then come over here and we write 4x plus 12 is equal to minus 1 over 4x plus 7 over 2. Now I think we start by multiplying everything by 4. We have 16x plus 48 is equal to minus x plus 14. Then we can rearrange easily. 17x is equal to negative 34, and therefore x is equal to minus 2. Substitute back into this equation. We have minus 8 plus 12 equals 4. So our answer for this is going to be minus 2, 4. And that's your answer.
Alright, welcome to the 4 maths segment of this video. For those who don't know, this is the segment where I give you 4 questions on the 4 different aspects of this one topic. Obviously today's topic is tangents to circles, and you have the pure, applied, proof and riddle questions as usual. Answer whatever one you want, or rule 4 if you want to, and check back in with me for the answers in just a moment. Alright, let's get into it. So for our pure question today, it's a pretty simple, just kind of more like a question you get at GCSE, honestly. So just, you know, work out the gradient of the radius. Obviously, remember it's perpendicular, and then substitute, rearrange, you know, all that jazz. For our applied question, for A, all you have to do is, you know, substitute the values of the points into the rearranged Pythagoras theorem in order to show that the radius has length of 5. For B, it's just a normal question from then on. You know, it's the gradient of the radius is 3 over 4, therefore tangent is minus 4 over 3. Substitute in, work it out, you get y equals minus 4 over 3x plus 10. For proof, it's very hard of a question today. This is probably the hardest question out of the 4 today. And I mean, unless you want to get into the very detailed maths of it, at FSMQ level, all you really need to know is that, you know, as you approach a single point on a circle, the circle becomes flatter and flatter and flatter until it's basically a straight line. And that's where the tangent is. And finally, for the riddle question, you're gonna substitute x for x into y, therefore you get 2x squared divided by 2, square root, rationalize, you get your first part of the answer, 5 root 2 over 2. And then for the second part, you're going to say that the gradient of the radius is 1 because, x is equal to y, and therefore minus 1 is the opposite. Substitute it in, work it out, you get y equals minus x plus 5 root 2. Thank you for making it to the end of the video. As always, I have a worksheet for this video in the description and in the pinned comment. Feel free to comment if you have any questions. I always respond for a week from posting this video. I also have a new half-termly article out starting today, which is on why do we use symbols in mathematics. Thank you once again, and goodbye. I'll see you in the next one, which will be on trigonometry.